Okay, so now what we have already seen what data science is, right? So now let's dive into the core, that is what is data. Okay, so here, okay, so data are values of qualitative and quantitative variables belonging to set of items, right? So but this is a definition, but if in short, what it means is anything and everything that is being measured in against or in order to measure performance of a process or a business or any technology or anything you or you look around and you see something that can be measured. That's data, right? And the data are basically the measurable values which can be categorized into qualitative as well as quantitative variables, and which belongs to that particular domain or that particular set, right? Now, data as a general concept refers to the fact that some existing information or knowledge is represented or coded in some form of suitable for better usage of processing, right? So you pick any domain, any business, any systems, any machine. Each one of them gives you some kind of data, right? This data can be useful and or cannot be useful. Who knows? It all depends upon the right purpose and the right intention of grabbing that data. Some part of data can be useful and some part is not. The moment we analyze this data to derive some insight or decision making, that data becomes information. Well, so we have defined information as well, right? So information is something that when you start using data for a specific purpose or to achieve a specific goal, that becomes an information. Okay? Data is indicated using a generic term called as variable. A variable is a term which temporarily represents the data or the type of attributes having the same characteristics, measurements, and properties. In order, like to basically, whenever you have to represent a data, right, to we call them a variable. Like to take an example, we human beings, right, we address each other, we call each other by something called our names, right? So we are identified with our names. Each one of us has similar type of properties but are unique properties as well. However, those common properties as well as the unique properties of a human being are defined by our names. Similar to in our data science, the data is represented using variable. So the variables can define characteristics, measurements, properties, and values that representing an indicator. Variables, again, like you defined earlier, it can be of two types: qualitative or quantitative variables. So what are qualitative variables? Qualitative variables are categorical variables where you can categorize the measures or the values that belongs to that particular indicator. For example, gender, nationality, zip code, grade. Gender, now two possible outcomes, male or female. Nationality, limited number of outcomes, right? It can, that list contains it may contain all countries that are on this planet earth, but that's not gonna change. Zip code, again, the values will be stagnant. Grade, again, ranging from A up to F. No one's gonna get a grade of G, H point something, right? That's those type of variables are called qualitative variables. Second is quantitative variables. Now, what are quantitative variables? Variables that can be measured and cannot be categorized. Those are quantitative variables. Example: height, weight, BMI, temperature, stock prices. So, if you see, all these variables, all this information is never static. It keeps very dynamic and it keeps changing over seconds, right? You keep measure looking at temperature, it fluctuates during the day, during the night, throughout the day, 24 hours. If you measure, there is a slight deviation in the average temperature. Same goes with stock price. Same goes with height, weight, BMI. On a periodic level, if you keep measuring, it will fluctuate, right? So that's the basic difference between qualitative and quantitative variable. Let's dive into more in quantitative data. Now, quantitative data can be further distinguished into discrete and continuous. Right? Discrete, when number of values is finite number of or countable number of possible outcomes. For example, number of apartments in a building. A continuous variable is when the data is recorded from an infinite pool of possible outcomes. Measuring the data by count is not possible. For example, temperature of a particular region per day. right? Some more examples: number of visitors a website has per day. Again, it's a discrete. Products sold in 4 hours, limited time frame, discrete. Speed of a train along 4 hours can be continuous. Weight of a person, again continuous, because we don't have a static or a standard um, observation over here, right? The next is definitely we know the data, we know what can be measured. Now, how to measure it, right? Now, there are different techniques by using which we can measure data and perform our analysis, right? So first, there are four basic types of measurement scales. First is nominal data, ordinal data, interval data, and ratio data. Okay? Now let's look at them one by one. Nominal data. Now data is sorted into categories according to a specified characteristics. This data cannot be arranged in an orderly scheme, where basically you cannot arrange them in some what will come first or what will come last. The categories bear no quantitative relationship to one another, but usually assign an arbitrary number to each category to ease the process of managing the data and computing statistics. Example: customers and their geographical location of residence. Now imagine the information of customers you have, and there are some demographics about the customer: first name, last name, date of birth, email address, contact number, and geographical location. Maybe we have zip code or a pin code, right? So now that information belongs to the customer but is not just limited with the customer, and it can be common with other customers. Similarly, you will have a list of different zip codes, but we cannot orderly arrange it, right, or sort it in maybe in ascending or a descending order, because that's not, we cannot place someone, no zip code is more important than other, right? So that's the nominal data. Second, ordinal data, the data that can be arranged in some order or ranked according to some relationship to one another, right? What can be the best example for this? Ranking, right? Or basically, you are comparing, you have a scaled or predefined measures for each of the categories. Well, let's go in deep. Ordinal data are more meaningful than categorical data because data can be compared to one another. Right? Most common example in business is data from survey scales. Now, how many of you remember you have filled out this survey when you may either approached a customer service of a particular organization, or you experienced something, some service or some product? They gave you a scale rating, right? How did you like the service or a product? Poor, average, good, very good, or excellent. And we happen to select one of the five, right? Now each one of them has carries a weight or a value to it, which on the back end gets measured, right? So, and there is no fixed unit of measurement, so we cannot make meaningful numerical statements about differences between categories. Now, very good or excellent. Now, for me as a person, very good would be a specific level of service. However, for someone else, the same amount of service can be good or can be excellent. So, you cannot clearly define it, but it's good for reference when we happen to orderly arrange it. Interval data. Now, data that are ordinal but have constant differences between observations and have arbitrary 0 points. Now, the most common examples are time and temperature, right? So, whenever you measure, for example, let's take temperature. Whenever we measure a temperature, we want to know the temperature, never get a static answer, right? It's all about a range. Well, a temperature on that particular day will vary from this to that, right? Now that's what an interval is. You specific the lower limit and the higher limit. And time is relative to global location, and calendars have arbitrary static dates, right? Another example is SAT or GMAT score. Scores can be used to rank students, but only differences between the score provide information on how much better one student performed over another. Ratio makes a little sense, right? In this is example. Ratio. Data is interval level modified to include a natural zero starting point. Right? With this, we happen to measure or compare from one member of the entity to the another. Now, most businesses and economic data such as dollar and time fall into this category. Now, you happen to find out the ratio, right? With how is one value is compared to another. Another example, a measured dollar has an absolute zero. Seattle region sold $12 million in March, whereas Tampa region sold 6 million. Means that Seattle sold twice as much as Tampa, right? Well, 12 by 2, that twice. That's how we measure the ratio. Next, different types of data. Now there are four major types of data that we have: structure, semi-structure, quasi-structure, and unstructured. Now if you see, even though the diagram is inverted, no, but structure, the basic and the most basic and the most desired type of data is the structured data set, where data having a definite data model, format, structure. Example, databases, relational database systems, where you have all the information nicely segregated along rows and columns, and it's very easily defined and you can actually locate each and every information. Now that's a structured data. So what is a semi-structured data? Textual data files with an apparent pattern enabling analysis, like spreadsheets and XML files, where the information is quite nicely arranged into blocks or into some patterns, but is not easily recorded. It's not relational, or it's not easily operational from different entities, right? Third is quasi-structured. Now the textual data with erratic formats that can be formatted with effort and software tools. Example, clickstream data. Now some online tools or you see the data which is segregated and you have to form a link between them. Now that's what quasi-structured data is. Unstructured data. Now data that has no inherent structure and is usually stored as different types of files. Example, text documents, PDFs, images, videos, audios, right? Well, are images, videos, and PDFs a type of data? Well, yes, they are absolutely unstructured type of data. In nowadays, we have all the smartphones which can recognize our facial expressions and can be used as a lock feature. Right? How do they do that? Our face, like for a human face, is being gets converted into highly qualitative and complex data, which is then analyzed and hence it's been identified. Now let's look at this particular table. Now this particular image of a data, it represents some attributes of counties. We have name, state name, area, and population in 1990. Well, it's nicely structured, right? Now if I have to find what was the population for Glacier, which is in 1990, I can directly go to first name. I look at Glacier. I go to Montana. Okay, state name is Montana. Area and population, 12,121 population. I can easily locate it, right? Simple. How about this? Now, the data that we have in front of us is a comma separated value, right? Now if you see, even though it looks like a word file or a note file, if we carefully look into it, we see, if we let's take the first sentence as an example: supplier ID, comma, ID, comma, product code, comma, and so on. So what we see is each attribute is divided or separated using a comma. So when we import this file, if you have to convert this into a relational database structured data, all you have to specify the comma is a separator. So the compiler or the system can easily identify that, okay, wherever they see it sees a comma, that's a division. So the information gets moved to the next column. Does that make sense? How about this? So you have dealership, we have information about the cars. Now the attributes make, model, year, color, miles, price, which defines a particular car, remain same across different blocks. However, the information that is against this variables is different. What does it mean? So right now we see there are three different type of entities which are mentioned, and about the information about them is mentioned in this, right? Now look at this. Cat images, right? So if you see, now what's the difference? If you closely see that the original image and converted image, the definition is a little different, right? It's slightly different. right? Now, how does this form into a data? If you closely look into it, each section of a image gets divided into smaller pixels. Pixels, a very famous term, right? How do we measure in our regular day-to-day life? We identify or measure the quality of a camera. It might be a digital camera. It can be a camera that is on your smartphone. How do we measure the efficiency? It's through pixels, right? So pixels basically are the minute division of an image which defines the in an image or a photograph, right? That again is a sort of a form of data. Audio data, we hear things, but when we move our audio to a system, we see a frequency, we see a wave that forms, which basically is the vibration of that creates the sound. And now that again is another kind of data, unstructured data. Well, having seen that, now let's look at the data scientist profile. So we have seen what data science is, we have seen what data is, what are the different types of data. So what type of profiles does a successful data scientist should have? Well, if we see data visualization, machine learning, mathematics, statistics, computer science, communication, and domain expertise. Now, these are foundational pillars of data science. However, if you see, statistics remains the top most required. Well, the goal of every data scientist is to and identify the right source of data, identify the ways to measure that data, identify ways to store that data, identify ways to validate that data. But what we are doing, the data, if it is measurable, we need some techniques to perform all these activities, which again comes from the statistical knowledge. So statistics becomes the most important domain within data science, followed by mathematics and computer science. It's all about computing, right? Next, machine learning. How you make your machines or your computers learn by itself and perform activities, inviting artificial intelligence or automation, right? Communication, whatever you have analyzed, how successfully or how easily you can interpret it in front of your stakeholders, right? Because they might not speak the language that you know, right? So it's very important to have good communication skill. Data visualization, extremely important. Whatever interpretation, whatever millions of rows of data you have, it has to be demonstrated what type of insights that it is giving us, has to be demonstrated in front of the right audience in a very crisp and concise manner, giving very less efforts to the person looking at it, right, to understand it. So looking at a visualization, it is very important for a data scientist to portray what that insight or what that information is we are trying to give to the stakeholders through very simple visualizations, plots, charts, reports, right? And domain expertise. Every data scientist should have some knowledge about the domain he or she is working in. Someone who is working in healthcare industry should understand some healthcare term as well, because you that may become an important foundation pillar of making the relations between the variables or relation between the aspects, right? So that's what data science profile is all about. Well, now give it a thought. What type of data you see? Look around you, look at some systems, look at some technology, look at some uh, operations that are happening around you. See what type of data it's giving out, how it's been measurable, and see if you can identify some sort of data which is not yet being measured. All the best.